Ugh. I have been printing these sheets for days and I'm still not done. I should have just become a programmer. Howdy everyone. So I've been thinking about clothes recently, and in particular where they're made from. So I mean, in my own closet, I've got stuff from China, India, Bangladesh, Vietnam, the list goes on. And I can't help but think, why are my clothes made so far away from me when I have a 3D printer?
And if you end up liking the video, consider subscribing. It's free, and you can always change your mind later. And this joke is definitely starting to chafe. Enjoy the video.
So if I Google, what is a shirt? It says a garment for the upper body made of cotton or similar fabric with a collar, sleeves, and buttons down the front. Okay, so we've already hit a wall. Sorry, a virtual wall. I need to massage this definition a little. First, my real shirt isn't going to be made of cotton or any sort of a fabric material. So let's tweak that to made of materials. That should be general enough. And second, the idea of buttons is sort of stifling my creative freedom. So let's change buttons down the front to say catches down the front. So in order to fulfill the contract that I have with the title and thumbnail of this video, I'm going to need to make an upper body garment made of materials with a collar, sleeves, and catches down the front. I should be able to do that just by squeezing plastic out of a hot nozzle, right? Now I hear you through the screen. You're saying, Brian, plastic is rigid and inflexible. If you make a shirt out of that, you're gonna look like Steve from Minecraft. Stiff arms walking around. Yeah, okay. I hear you, I do, and I promise that won't happen. Good enough? Okay, well, seriously, I am considering anything like Steve or even like Randy from A Christmas Story to be a complete failure. That will mean that I did not make a real shirt with a 3D printer. So I need to replicate a similar-ish freedom of motion with my arms, my shoulders, my neck, my torso. I need to be able to do kind of normal shirt-wearing things. That will be a success and I'll fulfill my contract with YouTube. The question is, where do we begin? Well, if I were buying a basic fabric shirt, I'd need to know what size I fit. Now, if I go to the store, I look for medium-sized shirts. That's what this is. It fits me pretty well. But if we're getting technical, I would say I have a 43-inch chest and relatively long arms. And if we're getting super technical, well, then I would take cross-sectional measurements of the circumference of my body, spaced roughly 2 inches apart, so I could build up a faux 3D model of my body. I am looking smooth and misshapen. And if we're getting exorbitantly technical, which we definitely are, then I would 3D scan my entire body so I could have a perfect representation of my size. I use this app called Scandy Pro. I haven't paid for it yet, so I only get 1 download per week, but it's really quite a capable app. It gets both geometry and color data that you can then export out to bring into any of your other programs. The file's gonna need some cleanup though. There's quite a bit of extra data and fuzz on things, so just keep that in mind. I scanned myself in a couple different poses, and the first one didn't come out that great. What is that? Oh dear God. Well, I finally got a pretty good version, and that's me. That's my size. And now that I know what size I am, I can design this shirt to fit me like a glove. A nice, comfortable, plastic glove. Well, I'm not the first person to make clothing out of non-standard materials. You've got knights from the Dark Ages, you've got these balloon people, and splinter-loving folks as well. But these all predate this adventure, so we need to examine the options that I have with respect to using a 3D printer to make a shirt. And I see 5 potential paths that we can take. One option is to 3D print my design in a thermoplastic polyurethane, or TPU for short. And it's a flexible plastic that you can print at home into almost any shape that you want. I can print out sheets of it, assemble them together into a shirt shape, and it could work. When you compare it to fabric, it's got a lot of flexibility, a little bit of stretchability. I mean, it's a contender. The second option would be to sandwich a layer of fabric or mesh in between a 3D printed part. So you can do this at home, print off a couple layers of a design, lay over top fabric or mesh, and then continue printing. So in this case, I've sandwiched these little hexagons with some mesh in between, so the entire structure is flexible. I mean, this is wicked, no doubt. I mean, I see spiky gauntlets or something like that in my future. There's plenty of ways that you can take this. But it's not 100% plastic, so for this project, I don't think it applies.
The third approach would be to take a really stiff, rigid material like 3D printed PLA and chop it up into long, slender shapes, like I did with this little test piece here. So I've really pocketed it out, and so I've given this rigid plastic a lot of flexibility. The trade-off is, of course, you can see straight through it. So as shirts go, they wouldn't do very well. And fourth is going to be chainmail. You know, this is a design from Zombo on Thingiverse, and it's this print-in-place chainmail. It's incredibly flexible. I mean, by far the most flexible thing I've talked about thus far. And people who do cosplay have been using this approach to make medieval chainmail for a really long time. But, you know, in terms of style, I'm not sure it tickles my fancy. So what does tickle my fancy? Well, option 5 does, and that's using articulated links like this in this awesome tie that I made in a previous video. You should go check it out. Aesthetically, this just really speaks to me. Rigid links using filament as the hinge, oh, it just speaks to my mechanical engineering sensibilities. Okay, so those are the 5 approaches that we can take to make a real shirt out of a 3D printer. So, which option is the best? Well, I'm gonna be smashing options 4 and 5 together. Let me explain. Any rigid body has 6 degrees of freedom. It can move along the X, Y, or Z direction, so that's 3 degrees of freedom, and it can also rotate along the X, Y, or Z axis. That's another 3 degrees of freedom. A hinge, like those used in option 5, limit those degrees of freedom down to just 1. Specifically, it can rotate along the axis of that hinge. And chainmail, that's option 4, technically doesn't restrict any degrees of freedom, within a certain range, of course, until the links run into each other. That's why chainmail has the most amount of flexibility of all these options, and a hinge would have the least amount of flexibility. And I kind of want a combination of these two. So I started with a normal hinge, and I collapsed those parts along their axis so that the pin became a sphere, and the bore that the pin sits in became a cup. And now I have a ball and cup joint, very much like the one you have in your own shoulder. And a ball and socket joint is only going to restrict 3 degrees of freedom, specifically all the translational ones. But the ball joint still allows all of the motion to happen in all 3 rotation axes. And this is great, because the hinge was 1 degree of freedom, the chainmail was 6, so 3 is basically right in the middle between the two. Yay, geometry! And so now the next step was to take this ball and cup joint and clone it around the sides of a link, and now start multiplying. 1 link connects to 2, connects to 2 more, and then array it out to have an entire sheet. Now I can't claim total credit for this approach. Someone on Reddit actually had reached out to me and shared with me a video on Thingiverse from a user, Jay Bergmans. He had created a flexible fabric that you could print in place on a 3D printer, and that's where this idea came from. His implementation was a little bit different. He actually has some conical features with extra space around them. So it accomplishes a very similar task, but I'm using a ball and cup joint in order to get the flexibility. So thank you, Jay Bergmans, for the inspiration for this method to my project. And after printing a sheet of this design off on my 3D printer and saw how flexible it actually was, I was really impressed, and it totally convinced me that this is going to be an awesome design approach for my shirt. The other amazing thing about this design is that these little links are actually second cousins to connects. You know, just like they can, I can unsnap and snap these together. They have a feature that has just the right amount of click to hold them together while they're being moved around, but also separable and reconnectable. As I start printing off more of these sheets, I can actually just snap them together to create even larger continuous sheets. No sewing machine needed, only a 3D printer. So far, things are looking pretty good for this challenge. So frustrating. That overnight print is completely wasted. I would say this is almost some piece of modern art. Failed build plate in blue. Anyone want to buy this for $3,000? Because that's what it feels like it costs to me right now. We have some of these other aspects of our definition of a shirt to get to. So we need a collar, we need catches down the front, and we need sleeves. So how are we going to accomplish those? The collar is basically just more fabric that's sewn on to the base shirt material in a U-turn sort of way. So that when you have your shirt coming up to your neck, the collar is going back in the opposite direction. So I was going to need a special link to help do that U-turn. So here's the design I came up with. It's essentially just the standard link, hacked in half, and then connected through the middle. And this facilitates, through the same snapping mechanism, a U-turn. And then we have the catches down the front of the shirt. So you guessed it, I need another special link.
And these catches are going to snap together just like the standard links do, but there's also an added latch design that goes on top that prevents them from coming apart easily. And of course, there's a very pleasant when you snap them together. Also, for aesthetics, I wanted to see a clear line down the front of the shirt going through the catches, just like you would on a normal shirt. And so I also designed these two straight edge pieces that basically lop off one of the connector bits in the center so that there's an open seam between, and the catches are what hold the shirt together. Look at all these links. Oh my gosh. I'm ready to assemble the shirt, I think. It's been almost 100 hours of print time on my little 3D printer. It's not including all the failed builds to get here, but I couldn't be happier, and I'm excited to start assembling the shirt. I tell you, snapping all these together, my fingertips are getting tender. Huh? So, what do you think? For me, I think the answer to our great question of this video is, I mean, it's shirt-like. I'll give it that. I have mediocre range of motion, up, down, out. It is an upper body garment. It is made of materials. I do have a collar. It has sleeve-like features, and of course it has catches down the front. I made a shirt? Question mark? Fit-wise, things could have gone better. Honestly, when I was putting this shirt together, it didn't quite assemble the way it was going on in my brain. But yeah, it's more tube top than tailored, and lengthwise, it's more crop top than full-length button down. In order to fix the tube top problem, I was gonna need a lot more special pieces. The sleeves in particular really needed to come out at like a 45-degree angle and be able to have a lot more flexibility in the armpits. These links just weren't gonna cut it, and so I had to kind of remove those features and compromise there. And to fix the length problem, this is a little bit easier. I just ran out of materials and print time, and I needed to start assembling the shirt. And on a fundamental level, I do have a bit of a design flaw. Now, the ball and cup joints in each of the links isn't problematic. They worked okay. But unfortunately, my problem ran into the fact that all the links are arranged in these columns and rows. And that led to rigidity in weird ways so that you couldn't quite get really complex curvature. Now, it does have flexibility, there's no question. This is a very flexible construction, but for the complex curvature of the body, you know, transitioning into the shoulders, it couldn't stand up to it. Needless to say, I now understand the problems of 3D printing a shirt quite well. And so if you're interested in seeing a version 2, leave a comment down below and I'll do a follow-up video. The shirt itself weighs nearly 2 kilograms, and that's about 4 pounds for my American friends out there. And if I remove the undershirt, I would describe the sensation on my skin as scratchy and uncomfortable, but somehow perfect. And of course, this design is fully customizable to my needs. If it gets hot out, I can unsnap these sleeves and have a tank top with a collar for any of my business meetings I have on the beach. And of course, once the meeting is over, well, I can unsnap the collar and be ready for volleyball. And of course, any 3D printed shirt wouldn't be caught dead without a 3D printed necktie as well. And there's actually a little special piece I haven't talked about yet up here on the top. And if I clip this on, 3D printed tie with a 3D printed shirt. That's pretty sweet. Now that I'm wearing this shirt too, I realize that there's some other benefits to 3D printing your shirt, because I've basically armored my torso. And so it should be stab and scratch resistant, right? All good. There's also like limitless accessory possibilities too when you really think about it. I can design them so they just snap on. Imagine snap-on pocket protector. You want a second pocket? Snap on a second pocket protector. Batman has his utility belt. I have a utility shirt. So my overall review of my 3D printed shirt is that it's amazing. It's probably too perfect if I think about it. Sure, it's got some, uncomfortableness to it. It doesn't quite fit right, but you know what? If something can reshape the global supply chain, I mean, that's gotta be good, right? If you wanna be a part of this revolution, then all you need to do is purchase the design files for this shirt and all the parts included at my website, which is linked down below. And then you just need about 3 rolls of filament and about 100 hours of print time. With that, you can make your own shirt. Maybe even replace your own wardrobe. Whew, you gotta get started. And if you enjoyed this printed shirt project, then you're gonna love my 3D printed necktie video. Go check that one out. Go make cool stuff.